Hello, welcome back once again. Today we're going to evaluate this interesting integral x divided by x cubed plus 1 dx. Okay, so let's get started. So let's find out this amazing trick which I'm going to show you guys in this video. This integral is the same as the integral. So up here we can write as x plus 1, then we need to subtract 1, right? Then divided by x cubed plus 1 dx. Now we're going to split the denominator as follow. The integral of x plus 1 divided by x cubed plus 1 dx, then minus the integral of 1 divided by x to the power of 3 plus 1, and then we have our dx, right? Okay, now at the denominator we're going to make use of the sum of two cubes, right? You know why? X to the power of 3 plus 1 is same as x to the power of 3 plus 1 cubed, right? So here is the formula for the sum of two cubes. A cubed plus b cubed is going to give us a plus b multiplied by a squared minus ab plus b squared. You get the idea? Okay, cool. Now x cubed plus 1, x cubed plus 1 is same as 1 cubed, right? So this is going to give us x plus 1, then multiply by x squared minus 1 times x, which is x, plus 1 squared, which is just 1, right? So let's first evaluate this integral. So let's call it a1, and let's call this one right over here our a2. Did you get the idea? So our a1 is going to be equal to the integral of x plus 1 divided by x plus 1 multiplied by x squared minus x plus 1, and then we have our dx, of which you see that this will cancel this, and here we have the integral of 1 divided by x squared minus x plus 1, then dx. So this integral is very simple from here, right? Because we're going to complete the square of that quadratic expression at the denominator, right? So let's think about this. We know x squared minus x plus 1 is same as x squared. So this is same as x squared minus, so this will be 2 multiplied by 1 over 2 multiplied by x, right? And then we have here plus 1 squared. But here this should be written as 1 over 2 squared, right? So let's write that 1 squared as 1 over 2 squared plus 3 all over 4, right? So sorry for the noise. So this is going to be here 1 over 2 squared, which is 1 over 4. But to obtain this one, we need to add a 3 over 4, because we know 1 over 4 plus 3 over 4, that will give us 1. Now let's use this idea that a plus b whole squared is equal to a squared plus b squared plus 2 times a times b. So we're going to use that idea right over here, because we have something squared minus, oh, okay, we're going to use the one of difference, not positive. Oh, so sorry for that. So it should be the one of difference, because we have minus 2 times 1 over 2 times x, right? So the one we're going to use is this one, a minus b whole squared is equal to a squared minus 2ab and then plus b squared. So compare that with this one up here, you'll find out that our a here will be x, right? And our b will be 1 over 2. So therefore we say that x squared minus x plus 1 is going to be equal to x minus 1 over 2 whole squared plus 3 over 4. So we just completed the square, right? So now our a subscript 1 is going to be equal to the integral of 1 divided by x minus 1 over 2 whole squared plus 3 over 4, and then we have our dx. So let's make this u substitution, letting u equals x minus 1 over 2, differentiate both sides, we get du is our dx, right? So a subscript 1 is going to be equal to the integral of 1 over u squared plus, now 3 over 4, we can write that as root 3 divided by 2 whole squared, because root 3 squared is 3 and 2 squared is 4, right? And we have our dx. Now let's record the standard integral formula. We have the integral of 1 over x squared plus something squared, let's say a squared dx, is equal to 1 over a multiplied by the inverse tangent of x over a, then plus c, right? So we use that here. So our a subscript 1 is going to be equal to 1 over root 3 over 2, that will flip to become 2 over root 3, right? Then multiply by the inverse tangent of u over root 3 over 2. So this will flip again at the bottom there, so we have 2 over root of 3. The inverse tangent of, that will be 2u divided by root of 3, right? And then plus c. Oh, forgot that, right? So there will be a plus c. So remember, our u is equal to x minus 1 over 2. Therefore, we finally get a subscript 1 will be 2 over root of 3. Then the inverse tangent of, so 2u will be 2 times x minus 1 over 2, which is same as 2x minus 2 times 1 over 2 will give us 1. And then we have divided by root of 3 and then plus c. Okay, cool. Then what is our b? Remember, a subscript 2, So a subscript 2 is equal to the negative integral of 1 over x cubed plus 1 dx. But I've made a video of this one, but let's just work it out in this particular video. So we can write this as negative 1, then divided by x cubed plus 1, and then we have y dx. So let's change the color. Let's make everything very nice, okay? So here, a subscript 2, we can manipulate this to be x squared minus 1. Then we need to subtract x squared. So we'll be left with only negative 1 up there. So we have x cubed plus 1, then dx. So if we split the denominator, we get x squared minus 1, then divided by x cubed plus 1, right? Dx minus the integral of x squared divided by x cubed plus 1, and then dx. So let's solve this one. So let's call that one b subscript of 1. So b subscript of 1 is going to be the negative integral of x squared divided by x cubed plus 1 dx, which we can write as negative 1 over 2. Then we're going to have 1 over 3, right? Yeah, cool. So 1 over 3, then we're going to have 3x squared right over here. Then divided by x cubed plus 1, and then we have over dx. Did you realize something? The derivative of the denominator will give us the numerator, right? So let's recall that the integral of f prime of x divided by f of x itself dx is equal to the natural log of f of x and then plus c. So with that, our b1 is going to be equal to negative 1 over 3 times the natural log of x cubed plus 1 and then plus c. Okay, now let's go to b subscript of 2. So b subscript of 2 is going to be the integral of x squared minus 1 divided by x cubed plus 1 dx. So up there we have difference of 2 squares, so it's going to be x plus 1 multiplied by x minus 1. Then divided by, down here, remember this is x plus 1 multiplied by x squared minus x plus 1, and then we have our dx. So nice cancellation going on, right? So b subscript of 2 is going to be the integral of x minus 1 divided by x squared minus x plus 1, and then we have our dx. So we can rewrite this as, so how can we rewrite this? So something really nice. So let's put this as 1 over 2 right over here. We're going to have 2x minus 2 divided by x squared minus x plus 1, and then we have our dx. So I have an idea for this. So let's check it out. So b subscript of 2 is going to be 1 over 2. So this is going to be 2x minus 1. Then minus 1 again, right? And then divided by x squared minus x plus 1 dx, right? So our b subscript of 2 is going to be the 1 over 2, the integral will split the denominator, 2x minus 1 divided by x squared minus x plus 1, right? So dx, and then minus 1 over 2, right? Because 1 over 2 times the negative 1 will give us negative 1 over 2, the integral of 1 over x squared minus x plus 1, and then dx. And we have done this one already in this video. So use that standard integral property. We know the derivative of this will give us the numerator. So our b2 will be 1 over 2 the natural log of x squared minus x plus 1, and then minus 1 over 2. So remember this here is 2 over root 3, right? So 1 over 2 times that 2 over root 3 will just give us 1 over root 3, right? So it will be 1 over root 3. So here 1 over root 3, then multiply by the inverse tangent of 2x minus 1 divided by root 3, and then plus c. Oh my god. Okay, so let us recall that a subscript of 2 is b subscript 1. Okay, b subscript 2 minus b subscript 1, which is same as b subscript 2 plus b subscript 1, right? So that is going to give us, so a subscript of 2 is going to be b subscript of 1 plus b subscript of 2. So let's write this one first. 1 over 2 natural log of x squared minus x plus 1, right? And then minus 1 over root 3, the inverse tangent of 2x minus 1 divided by root 3, right? Okay, cool. So let's check the b subscript of 1, which is negative 1 over 3 natural log of x cubed plus 1, right? So this one right over here is negative 1 over 3 the natural log of x cubed plus 1, and then plus c. And then our a subscript of 1, do not forget that is 2 over root 3 the inverse tangent of 2x minus 1 divided by root 3. And we're going to add everything together to get our integral, right? So our integral will be the sum of everything. So our integral now, let's call that integral I, is going to be a subscript 1 plus a subscript 2. So let's add them up. So here we have 1 over 2 the natural log of x squared minus x plus 1. So this one right over here will be negative 1 over 3 the natural log of, we know x cubed plus 1 is same as x plus 1 multiplied by x squared minus x plus 1. Don't forget that. And we have negative 1 over root 3 the inverse tangent of 2x minus 1 divided by root 3, and then plus a1, which is plus 2 over root 3 the inverse tangent of 2x minus 1 divided by root 3, and then plus c. Now let's simplify nicely with the property of logarithm. Remember, the log of a times b is equal to log of a plus log of b. So we use that idea here. So our I is going to be 1 over 2 the natural log of x squared minus x plus 1, right? Then minus that will be 1 over 3 natural log of x plus 1 plus, oh, we have a negative 1 over 3 outside, so we're going to have negative 1 over 3. So negative 1 over 3 the natural log of x squared minus x plus 1. So we add these arctangents, right? If you add them, they are going to give you plus 1 over root 3, then the inverse tangent of 2x minus 1 divided by root 3, everything plus c. So now combine the natural logs, so we get I is equal to, so we have 1 over 2. So what do we have? So 1 over 2 minus 1 over 3 is 1 over 6. So we have our answer, 1 over 6 the natural log of x squared minus x plus 1, okay? And then we have minus 1 over 3 the natural log of, that is x plus 1, right? And then plus 1 over root of 3 the inverse tangent of 2x minus 1 divided by root 3, and then plus c. So this is our solution. Thank you for watching. Please subscribe.